Okay, let me, without further ado, we're going to make a transition to this next step. And Mario Uchimiya is going to be leading all of you in an interactive hands-on tutorial using NMRbox. So this is where we're going to start to switch. He's first going to tell you about what you're going to do interactively on your own after the coffee break. He's going to show you the steps. But by way of introduction, Mario is also a perfect person to lead this. He was a postdoc. Well, so he got his PhD in Japan doing NMR marine metabolomics, and he came to a and he came to a postdoc with Marianne Moran, where he did some really wonderful particulate marine metabolomics and collected the data in our lab. And I was so impressed with what he was doing. I said, you can't leave for Japan now that your fellowship is done, so stay with us. And so he joined our group. Now he's a staff scientist in this NAN program. He's also still working on CoMP, but he's in charge of our metabolomics knowledge base right now in NAN. So he's the person who's responsible for optimizing pulse sequences, coming up with protocols, coming up with workflows, things like that. And so, so he understands the marine science world and metabolomics world very well, and is really the perfect person to be bridging this world. So without further ado, Mario.
Thank you, Art. I want to use slides and other homepage websites and NMRbox, and I will go back and forth. So I don't use the full screen, so this is about Metabolomics Toolbox, and so this is one of the useful tools to analyze NMR data, and today I'm going to explain how that works, and later you can try that using your NMRbox. Before I start this, this toolbox is developed and maintained by many persons, and so this is a team effort. And Stephen first started this activity, and recently Michael led this one very actively. So first I have to acknowledge that. And also our toolbox is already on NMRbox, and when we have some issues, every time Gerardo, Adam, and Mark are the ones who always help us. So including all the NMRbox team, I want to thank all of them. And also this session is supported by so many people, and I want to thank all of you. Okay, so again, we have two sections today. First one is instruction. So I'm going to explain what is the toolbox. And after that, we move to the hands-on. You can try the toolbox using your NMRbox on your laptop. This is the same slide Art showed yesterday. So when we do metabolomics, first we have to collect samples, then we have to process samples. Then after that, we can start collecting data using mass spec or NMR, and that's the data collection part. And after that, we can move to data analysis. And the starting point is spectra. And using that spectra, we do some statistical analysis to extract useful information to test some hypothesis or to generate some hypothesis. So this is the general scheme in metabolomics. And yesterday, Art already explained metabolomics in general and NMR in general. So these sessions focuses only this data analysis. Okay, let's assume we already have good NMR data set, and we want to achieve some goal using that raw data, right? And the goal depends on the study. So one study may want to do group comparison, like group A has more compound than group B, something like that. Or we could do some correlation. Compound C increases with temperature, salinity, or locations, something like that. Or we could do some multivariate analysis, like group 1 and group 2 are different. So the goal depends on the study, but anyway, we have to achieve goal using raw spectra. So the question is how? This is not a marine sample, but one example of one-dimensional proton detection experiment. And this is just one spectrum from one sample, but that sample has many metabolites in it. And also in this proton detection one-dimensional experiments, when proton and proton has J coupling, even one proton split into multiple peaks. So in the peaks overlap. And so even one sample spectrum looks a bit complicated. And this is also true when we have more samples. So this figure is from 300 samples. So now we have more complicated figure because different samples have different metabolites, and Art just said, but depending on the sample condition, peak moves a lot, and that's why when we have many samples, the stacked plot is really complicated, and we have to deal with this to achieve a specific goal. And there are several key steps to link the raw data and the goal, and they are referencing and region removal, alignment, binning, peak picking, normalization, and scaling. I know many of you are already familiar with these steps, but since these steps are really important, and also we have some students on Zoom, so I want to explain each step very briefly. So we have raw spectra, and first thing we have to do is referencing. Referencing is a step to set chemical shift standard peaks at 0 ppm. So this is the whole spectra, and our interest is always the distance between the internal standard peak and other peaks. So the internal standard peak should be at 0 always. And but if we look at the original data set, so this is from this red box. So we are now looking at the chemical shift of 0 ppm. I can see many peaks are at 0, but I see some peaks that are off. This is not good. So first we have to fix this. And after referencing all the peaks at 0 ppm, so now we have the right distance between this peak and other peaks. So this is always the starting point in NMR metabolomics. After referencing, the next step is region removal. Region removal is a step to remove unwanted peaks or regions computationally. So we could remove unwanted peaks experimentally using NMR, but that's not always perfect. And for example, if we use water solvent, we always have some water peaks in spectra, and we have to deal with that. And so that's why we do this computationally. So now we are looking at a water region of the original spectra, and we can see water peaks at around 4.7 something ppm. And we can see other metabolite peaks. So water peaks are really huge, and this is not good. This is not what we want. So first we have to remove this one. And after the peak removal, we don't have any water peaks here, and they are really flat because we added just 0 values in that region, so they look really flat. So this is a step to remove unwanted peaks. And this is an example of water solvent, but if you use other solvent like methanol, you can do the same thing. Or if you have giant endoregions that don't have peaks, they are not necessary in the downstream steps. So you can, or you could remove those regions in this step as well. Okay, after we remove the regions, the next step is alignment. And this is exactly what we just discussed. So we are interested in the position of the peaks, that is chemical shift values, but they often move depending on the sample condition, like pH, temperature, ion content. And so we have to correct this, and that's the step of this alignment. So if we look at the original data set, we have peak shifts in this region. We have peak shifts in other region. So this is not good. And if we do alignment, now we have one peak in one region and other peak in other region, and they are aligned. So this is the alignment step. And there are so many different alignment methods in this field, and but one important point is we always need manual inspection of the alignment. We don't have any single alignment method that works perfectly for all the studies. So after alignment, we always have to check if they have a good alignment. Okay. So next is pinning or peak picking. This is an optional step. So one may do this, one may not do this, but this is a step to define bins or peaks. And the purpose is we can reduce the number of features by this step. So if we look at the spectra, they look like lines, but actually we have so many data points in lines. So, but if we set a pin to a specific peak, now we have only one feature. So this is a feature reduction step. And this is especially useful when you have a large data set because you can reduce the number of features. So this is just one example of binning. We have one peak in one bin and other peak in other bin. So this looks good. And this is done automatically, but again, we always need to check the bin results. This is one bad example. Now we have one bin here, the other bin here. So we have one peak here, but this peak is divided in two bins. So this is not really good. You will lose the information of those peaks. This is another example. Now we have one bin, but we have two peaks in one bin. So this is not good, especially when they are from different compounds. So we lose the information of those peaks. So that's why we always have to inspect the results manually, and we have to make sure the bins are set correctly. Okay. Next step is normalization. We need this step to compare samples. So that's why this step is often called sample operation. And here's one simple conceptual example. So for example, sample A has high value than sample B, so red and blue. So this looks like sample A has more compounds. But if we go back to the metadata sheet, actually we used more starting material for the sample A and less material for sample B. So if we normalize this, actually they are the same metabolite content per starting material. So this is a normalization step. So if we don't do this, we may have a different or wrong conclusion. So that's why this step is really important to compare samples. And there are so many different normalization methods in this field. And people may normalize the data using cell counts or cell density, or others may use more computational normalization like constant sum. And we often use this PQN normalization. And here is one example of PQN. PQN is called PQN in this field, but this is also often used in other fields. And for example, in sequencing field, they use this normalization to correct the sequence depth. But in NMR metabolomics, we use this one to correct the dilution factors of the samples. And so now we are looking at 600 sorry, 300 something samples. And the white dots are the mean values of those samples. So the mean values are variable between samples. But after this PQN normalization, they can have a very similar mean values. So that's the PQN normalization. And now we already did this normalization, we can compare the samples. So this is one example of, I think, mean values for group 2 in red and mean values for group 1 in blue, and chemical shift versus peak intensity. And we have to do detailed statistics, but it looks like group 1 has more those CoMP metabolites than group 2. So that's something we can say because we already normalized the samples. Okay, the last step is scaling. Scaling is different from normalization. And scaling is often called feature operation because our interest is now feature to feature, not the sample to sample. And here's one simple example again. If peak A is like this in red, and if peak B is like this, and they are variable. And if we use this data set in the downstream multivariate analysis directly, most of the sample distribution will be defined by this giant peak B. And this is not good because we also want the information of peak A. So that's where we need scaling. This is one example of auto-scaling, but after auto-scaling, all the peaks have the same mean values and standard deviation. So now we can move to the multivariate analysis. This is one example of PCA. So we are looking at PCA score plot and PC1 versus PC2, and samples from group 1 are red, and samples from group 2 are green. Based on PCA, looks like we have some difference between group 1 and group 2. So we have to do more sophisticated multivariate analysis after this, but even from here, it looks like they have different metabolome. And we can also do some loading plots using PCA results. Now we are looking at PC2, and x-axis is chemical shift. So this indicates those peaks are more abundant in these samples. And I can't see this, but these peaks are more abundant in these samples. So, so they might be compounds that are separating the groups. So this is something we can do in other multivariate analysis, but this is the starting point, and we can say this because we already did the scaling. So Metabolomics Toolbox is a set of functions of spectral processing. And our toolbox works with MATLAB, and they are already in NMRbox. And that toolbox has all the functions you need to do the basic spectra processing, like referencing, region removal, normalization, scaling, PCA. We have other functions. And then anybody can use this toolbox to create some figures from using their original spectra. And the figures today I just showed are all created by this toolbox. So this is really handy. Anybody can use this. But our real purpose is more about fair science. So when we submit some paper, we always deposit our raw data, processed data, processing script, and metadata. And they are in some databases like Metabolomics Workbench or NAN portal. And that's really good. But the problem is, for example, in our case, we have to use MATLAB. So if somebody wants to reproduce our results using our deposit data, they need MATLAB. But MATLAB needs license. So that's not really friendly. But our system is already in NMRbox, and you don't need to worry about licensing for MATLAB. So anybody can go there and reproduce the data using our deposited data. So our real purpose is really fair science. Okay, Mark already showed this yesterday, but so we have NMRbox, and if you want to use our toolbox Metabolomics, you can search for Metabolomics, and there are different useful metabolomic tools, but our toolbox is here. If you click on this, we are now version 1. And if you click on this, you can see the available virtual machines. And it looks like most of all the machines have our toolbox. So you can just pick one from any of the virtual machines. So this toolbox is really stable, and we are satisfied with this, but we understand it's not always easy to use a new tool or new software. So we also have wiki for that. So if you search for Metabolomics Toolbox wiki, we have more information for that toolbox. For example, so this explains the functions, or what's the possible next steps, and we have information for all the functions. Or maybe you can't see this, but we have some decision trees for this toolbox. So if you need more friendly information you can use this wiki as well. And this wiki was this activity was led by, again, Michael, and he has a substantial contribution to create this wiki. Okay, in the next session, we want to move to the hands-on, and then you use your NMRbox. But to use our toolbox, we have to use MATLAB. And let me use 5 or 10 minutes to just explain the MATLAB tips. So depending on the versions, you may see a slightly different window, but MATLAB always has the same components. One is current folder. You can use those files in that folder. And the next one is command window. So you can just type command. And MATLAB has workspace. And the last component is script. And MATLAB calls this script, but we often call this workflow. So they are almost the same definition. Okay.
Could I just
go ahead.
Comment on the workflow, or the reason why we refer to it as a workflow? We start with something like this template that Mario's going to, or this is a real workflow on a real sample. And we'll oftentimes take that, but then we'll have specific steps that we use for a particular study. And we'll remove things, or we'll add things, we'll add different, there are a lot of functions that Mario's not going to tell you about today. But that becomes a history of your sample, and that should just stay with the study. That's a permanent record. That's the best record that you'll ever have to know what you actually did and to tell others in the community about it. So I recommend that when you get something that works, you see a nice plot, you're happy with it. That's it. That's frozen. That gets deposited with your data. So that's why we refer to this.
Thank you. So now here I have my NMRbox, and I already launched MATLAB. So again, we have.
You want to show how to start MATLAB? Well, you can start.
Now.
It's up to you. Sorry.
Yeah, let me just explain this quickly. So we have current folder here again, and we have command window here. So command window is just command window. So if you do like A equal 1, A equal 1. So what I just did is I created variable A, and that's 1. And if I hit the enter, MATLAB moves that variable to workspace. So now I have a variable A, and that is 1. So you can do the same thing like B equal 2. Now I have other variable B. You can do something like variable plus variable. Now I did A plus B, and that's 3. But the slightly different thing just happened. So we have a variable answer in this workspace now. And because I didn't set any variable in this step. So if you want to set a variable, you can do like C equal A plus B, and now I have C. And this is very useful because if you do like 7 plus 8 next time, answer is already a different value, and you don't have the last one you used. So it's always better to have a variable. So that's how MATLAB works. And command window is really good, but if you have so many commands, that's not very easy to use this command window. And that's where we need script or workflow. Now I will do like, you can do the same thing like A equal 1 and, oh, sorry, I should. Oh, sorry. Now I have variable A, like B, C, okay? And this is really handy when we do metabolomics analysis because you can do something like say rho NMR equal, say, now we have 10 samples and they have 1,000 features. Oops, sorry. We have raw spectra. And if we want to process the spectra to process NMR equal raw NMR, say, NMR. I just process the spectra. If you have other processing step like process NMR2 equal, say, process NMR, divided 1. So basically, you can have all the steps you did and all the outputs you got, and you can just deposit them to the database, and anybody can reproduce your steps. Okay. That's one thing. Yeah. One more point. I just made this one, and now you can see horizontal line here and other line here. So now there are sections. So if you want to run a section, just click on the section. There is a shortcut, but if you are not used to this, just click on this section today. And here's one other button called run, but don't hit this today because our script doesn't work that way today. So if you click on this runs all the commands at the same time, but we want to do this step by step, okay? So that's the sections, and run a section. Again, use this, don't use this. Okay, this is also important. Sometimes MATLAB says busy. That's really busy, and just be patient. Seriously, don't click on run over and over again. They really hate that. Okay, don't do this. Okay, errors. You already, I think, know this, but I already got so many errors already. Let me go back. Let's make some error. Okay. When you see some red message, that's an error. And when you get an error, something is wrong. Here I just typed D and hit the run section, and this says you don't have variable D. So that's the error. And errors are so frustrating, but my experience is MATLAB is 90% always, almost always correct. So something is wrong on our end. For example, today, if you skip some steps, you get some errors. If you use some wrong variables, you get some error messages. Okay. What do you think? Do we want to move to the hands-on, or?
I suggest you walk them through getting MATLAB fired up from the terminal. And then let's take pictures. Let's take a coffee break, and maybe now would be a really good time. We won't jump into your analysis yet, but open up your laptop, hook up, try to connect to the virtual machine, and raise your hand if you can't get onto the virtual machine. But Mark is here. He can help you with that. Ricardo's here. I'm here. We'll all help you connect to the virtual machine. Deanna is
yeah, Deanna's here. Yeah, is Max here? Max is not here. Okay. At least find these faces. They are really MATLAB experts.
So see if you can you do that, or raise your hand if you're struggling. One of the difficulties, the reason why I'm taking so much time is that having been an attendee in several workshops that I don't really know what's going on. You know, once you miss some of these critical first steps, and then you just see Mario up there typing away or something. I mean, we're gonna be actually letting you go through this workflow on your own, and we're gonna help you with it. But you kind of, if you're not starting right, then you're not gonna get into it.
And remember, when you start NMRbox, the screen resolution is generally low. You do that just so it will always work on whatever device. But from the first things you're going to want to do is go up to the upper right corner, click the little NMRbox icon, go to screen resolution, and toy with changing the resolution.
Do you want to go through to your NMRbox? And yeah, once you exit.
There's also at the top of the VNC window, there's like a full screen mode too, which you can play with some of those settings there for sort of expanding things out that on your screen.
What mode, or what do you do for that?
This is right. Totally on the VNC. So, all right. So I'm here at the website. I click on the little VNC and it's
That's nice. I never change resolution.
No, this
So
is really
nice.
you learned it.
right, but like, oh no, but I have two VNC. So it's default to the one. So let's just leave it. So then I go to import. For connections, I go to my trying to use the real here. Right, so it's not just launching it. So then it's like goes off into how do I get it to not because like when I have two VNC cards because like it's just a whole to the other one. Well, I guess I could go here.
Are all of you or any of you who's familiar with Linux and the command line? And who has never seen the command line? It's totally fine if you haven't. No, it's not a problem. We'll walk you through the basics.
Yeah, so then I get this email that's server specific.
Well, that's ultra VNC.
Right, because that's my problem. I have two VNC cards. I installed the VNC on your thing here, but if I go to the download,
Yeah,
it's
you need to open up the real
not the other. Yes. Well, I was never really good. Yes.
So can we, let's show them kind of right there this chart. And then I want to just, I'm just going to walk through. If you give a couple.
How to
Okay, so they
open the tunnel.
Okay. Here, you should, I think. You're all passed out. I'm sorry.
Yeah.
Here's some cheat sheets.
That's so, okay, I was gonna say, okay, I just have a first.
That was a great introduction. You and Nicole both did great jobs. No, really, I know nothing about NMR. I know one. But that was an awesome. I have one question
Sure.
about, can you show me you had your processing steps? I'm curious.
Sure.
I didn't want to bother, but no, this was, you guys should do, you and Nicole should do lots of any future of these work on. So I'm curious here.
Yeah.
So can you take advantage of the peaks that you don't want, like the water and the solvent, to help with the alignment and the binning?
Yeah, that's really a good point. We can.
Okay.
For example, methanol.
Yeah.
Yeah, that's 3.3. So we don't have an internal.
Okay.
Yeah.
Yeah, I was just
Yeah, that's a really good point. That's what we do.
Oh, okay.
Yeah,
Okay. So
yeah.
you then cheated. Okay, because I was wondering, because it's like, if it's, I mean, we do that in mass spec, like if it's a huge peak,
Right.
it's across your sample,
Right.
you can use it.
Right.
Even if you don't want it.
Right.
Okay, I was just curious.
That's true.
Okay.
So let me take just a couple of minutes to orient all of you while Mario puts his NMR box up here to command line. Okay, so if you're already an expert on command line, you don't have to listen. But so first of all, if you're going to be doing any work in a Linux environment, you really have to get familiar with this black box that nobody likes to look at if you're not used to looking at it. And Mario will show you here on the screen how to get to that black box. So you can, so he'll close that. So you get this thing on the bottom. You see that little tool thing on the bottom? It's right there with the $sign. So he's going to click that. Now there, you can do a lot in Linux by point and click in a graphical interface, but you notice that Mark displayed, he navigated around his virtual machine through the terminal. It's so much easier. It's so, you know, anybody who likes Mac or Windows, you get kind of used to pointing and clicking and having folder structures. That's really inefficient. So if you're going to do any real computation, you got to kind of get comfortable with this, and you can't actually start MATLAB without this. So when Mario brings it up, I'm just going to give you a couple of commands, and you can just make it. You can Google like Linux cheat sheet or something, or Linux shortcut command. There you go. Starting important Linux commands, and you will find this list and a few more. So he's right there, and if he types pwd, that's going to give his present working directory. He's going to enter, and it's /home /NMRbox /Uchimiya. And that tells him where he is. So when he first logs into his account, then this is where he ends up. He goes into this home folder, and you'll have yours will be /home /NMRbox, your username. Now he has to change folders now, or directories. So he's first going to type ls. This is going to give him a list of everything that's in his folder. And these, and he has the blue documents are, well, they're all folders, right?
Right.
Yeah, and I guess that the green indicates that it's a group folder or something. So let me tell you what he's doing here. So type, go back to your home. So if you just type CD from anywhere, he gets back to where he was, or to his root directory. Just CD return will go back to his root directory. If he wants to change to, so this class is under events. So if he types CD, now here's important shortcut number 1. So he'll just type capital E. Now he'll push tab. And it gives events. So you can get around this really quickly if you use tab to get shortcuts. And if you're in the place where there actually is an event or any directory that started with E, capital E, it's case sensitive, it'll go there. So now he'll push enter. Now PWD. Now it says that he's in, and that little squiggle says that the little tilde / events means that it's in his home directory, and then events on top of that. Now type ls. And now there are different directories. Mario's been part of other workshops, and there's a README file that will tell you about how these things work. But the workshop that we're in is this 2022 NAN CoMP. So CD, and then you can do this tab. I'm really lazy, so I tab every opportunity I get. So I'll like to tab, and then it'll find 2022, and then it'll find different choices, and then N, and then tab, and then it finds the whole thing. Now ls, and then there are these files in here. So the Edison will have the PowerPoints that I gave yesterday. The resources _ papers will have the papers that I've added. It includes the whole paper that she talked about today, the ones that I referred to yesterday, and then the Uchimiya. And then there's the schedule if you want to look at it. So he's going to CD into that, and then type ls. So you see we've used PWD, ls, CD. That's it so far. But that's really what you need at the moment. There are some other fundamental important commands that you need to learn pretty soon, but not for today. So there's just one folder in here. So CD and then capital NAN. He's in this workshop, and now you're seeing something that looks like what he was in when he was in MATLAB. There's data, results, and scripts, and so now this is where this MATLAB demo is located. Okay, so from here, fire up MATLAB, I think it's that. So if you just type MATLAB, all all lowercase, just one word, MATLAB, enter, MATLAB will come up. Everybody at that point where you have MATLAB on your screen? Okay. Now, and I think that we're getting to the point where this would be a good stopping point. To run this workflow, watch what Mario's doing on the screen right now. And tell them what you're going to be doing, Mario.
So you can see script results data in your current folder. And if you double click on scripts, you can see one script, and just double click on that, and you can have this example script on your MATLAB.
That's your workflow. And so the thing that most of you will make, if you make your first error, if you get an error on the first command that you run, that's almost certainly going to be that you weren't in the correct directory when you started this. So you got to be sitting in this scripts directory, open up that script, and then you start that command. And then within that script, it's going to change directories and things in the script, but you have to be at that starting point to make it work right.
show that pack for the scripts directly big for those of us who were not listening the first quarter?
Yeah, this is the time to get any of that kind of stuff because we're
It's pulled out on me because I'm not listening to them, but I missed for the scripts directory actually. I don't have my glasses on.
So do you have this one? MATLAB. Oh, yeah, sorry. Yeah, this is maybe too small.
No, I don't have my glasses. Okay, that's my fault.
The other thing, I asked Mario to change to fire up MATLAB when he was in the Metabolomics workshop folder. He could have done one more CD into scripts, change directory and spin in scripts. Then he would have just had this workshop script and then start MATLAB. MATLAB will go to that directory that you started it from. So I just wanted to show you that you can change directories in MATLAB as well. Fire up that term in that directory. Yeah.
You're working on something. Can you open up what you do?
Really good question right here. Chris asked, if you are working in something else in MATLAB, can you open up this thing and do something else in MATLAB? And the answer is sort of yes and sort of no, but be careful, I guess is the real answer. If you just totally different things and there are no overlapping variables or functions or definitions or things like that, you're probably totally fine. Especially on NMRbox where they have tons of memory. But if you're working, for example, on a different function in our toolbox, that's probably going to end up conflicting with what you've got here. Or there's a chance that you will define some other function that if you tell it too much information, like you also define a function, but it's a little different right now. It's the same name, then it'll go crazy. You'll get either errors or results that you're not sure.
I like to use the new live script.
Yeah, the safest thing is to start from scratch. Just quit MATLAB, start up again, and save your other job. You can always. So let me actually make a couple of comments before we'll have the photo in just a minute, and then we'll have a break. But the one thing I want to say is that you can save whatever you're doing in MATLAB. You know, so sometimes you spend hours going through these scripts and you're looking at data and you're making changes. You have to go lunch, you have to go to class, you have to sleep. You can save your entire workflow. You can save a .NET file. And everything that you've done to that point, all of your workspace is saved in a single file. Then you just read that file in and you recover all of that workspace. So you can go right back to where you started from if you save the workspace. So up at the save button on the MATLAB panel, up right there. So save will save your workspace. Or in this case, it's going to save the editor because it knows that it's in the edit. If you make a modification to this, you can save the script. And actually, Mario has his save as. One thing that I would recommend, good practice, if you have just one copy of this script, we can send you another one if you screw things up. But you can just also save as, and say my copy. And then you can work with that copy, and then if you find yourself messing it up, then you can open up the original again. That's a safe way to do it, and when you're learning. And I want to make one more comment, then we're going to take a picture. And the comment is we indicated in the material that we sent out to the class that there is a MATLAB onboarding or on-ramping, I think they call it, a 2-hour free interactive tutorial. It's really useful information. Even if you've seen it before, I bet that everybody will learn something from it. It's it's basic stuff, but it's really useful. It's an interactive video. You type commands. You do it's worth your 2 hours if you're a little uncertain about your familiarity with MATLAB. So with that,
Just one.
well, yeah, sorry, go ahead.
So before we move to the picture, so I already gave you all the printed material, and that has all the information. And if you follow that, you can create the same figure from the original data. So that and the PCA is today's goal. So if you can see that, that's it. Okay.
Maybe it's worth mentioning that you can write comments to this to workflow using Postman.
Great
Yeah.
suggestion. Okay. What Ricardo just said is now. Where is my? So now we see three different things. The first one is %, two symbols. That's title in MATLAB, and they are in green. And next thing is one symbol, %. That's comment. They are also in green. And when you see green lines, they are not codes. So you don't need to run this. If you click on the run section, nothing happens because they are not codes. And codes are always in black. So if you see some black lines, that's what you have to hit where you have to hit the run section.
And then if Mario does a return and puts another double percentage, he can start another section, the title 2. And so like the run section above that he had highlighted before, that little thing that you do, the little tab on the top, that would do one of these sections at a time, wherever whatever's highlighted. You see the blue on the left panel, the left of where he's typing, to the left of the line numbers 1, 2, 3. That blue, and now it's down. Now the blue is moved below. That the run section will run whatever is highlighted in blue.
I have a question.
Hmm?
Do we need to run it as a live script?
Say that again.
Do we need to run it as a live script?
So what do you think, Mario? Do you like live script?
Either works.
Either works. I always do just the old-fashioned command lines, but live script I think is a nice thing. It's really a good way of running these codes. One thing when you get into the workflow, we're going to be here, so you just should raise your hand, say I'm stuck, I have an error, I'm getting whatever, I don't know what I'm doing. But there are some sections that you can't skip, so you can't just go from the top down to the bottom, like, oh, I'm going to skip all this stuff and run PCA. It won't work, because each step you're renaming files. So like after Mario does an alignment, then it's a rename data file that indicates that the alignments that happen. After the normalization, there's another renamed data file. After water is removed, there's another renamed data file. So you really have to go through those steps, and then you get down to the PCA and you say, look at that, now I can do it. But if you want to see what an error looks like, just read in the data at the start and then try to execute the PCA at the bottom and say you'll see a big error. That's not defined.